All right, now we're going to section 6M. These are word problems, and it's the first page is to get used to taking two equations with two unknowns and turning it into one equation with one unknown. Once you get a word problem so that it's one equation and one unknown, then it's ready to be optimized, or you're ready to take the derivative to find the optimization. When you have two unknowns, you can't do that yet. And you'll see how that works later. But on this first page, all we're doing is eliminating one of the two unknowns. So here we have this equation, and we have this equation, and they both have the unknowns b and h. Okay? What we want to do is we want to get one equation with one unknown, and then we're going to eventually use that to find the optimum solution. You use this in problems where you say something like you have a certain amount of fence and you would like to enclose the largest amount of area with this amount of fence. In this case, let's see, we don't actually know what's going on, but it looks like an area equation, and then the difference between the two sides of the rectangle is 7. Okay, so use the constraint, and this is the constraint here, to express b in terms of h. So b in terms of h means you're going to have b equals something, something, something with h in it. Okay? Doesn't matter how it looks as long as there's only h in terms of variables there. So we're going to take the constraint equation. How do we make it so that b is on the left by itself? We're going to add h to both sides. That will get b by itself. So this would be b, and the right side is going to be 7 plus h. Okay, so that's the answer for part A. And that's the first step to making an area equation with only one variable. B, it says express A in terms of h. So we have A equals BH. A is in terms of B, and it's in terms of h also. We need to get it so that it's in terms of only one variable, and it says to have that variable BH. Not BH, but BEH. Okay? So we leave, or we're going to take b here. Instead of b, we're going to put 7 plus h. Okay? So we're going to 7 plus h. And that's going to be multiplied times h. Okay? So now we've rewritten a so that it only has the variable h in it, no more variable b. And so now we can either leave it like that, or we can multiply it out and get 7h plus h squared. Okay? So that would be the answer to part B. Now 3, 5, 7, we're going to be doing similar things. So p equals x squared times y is subject to the constraint 2x plus y equals 5. Use the constraint to express y in terms of x. Okay, so let's see. How do we get y by itself on the left side? We would subtract 2x from both sides. So subtract 2x from this side, we get rid of 2x, and subtract 2x from the right side, and then we'll have 5 minus 2x, and we're done. So that is the answer for A. Express p in terms of x. Well, right now we have p in terms of x and in terms of y, but it says to express it in terms of x only. So the x we can keep, and then we need to substitute into y something that has x's in it. Hey, how convenient, we have it right here. So we're going to substitute 5 minus 2x in for y, and we are basically done here. Okay? This is the answer. We can simplify it or multiply it out, but we don't have to. 5. L equals 2m times m quantity x, m plus x, subject to the constraint, and that's kind of a messy one. Express L in terms of m. Okay, now they skipped something, because usually in the first 3 problems they told us, or the first 2 problems, they told us that we were supposed to find y in terms of x, etc. So to get L in terms of only m's, look what we have here. We have an x here. We need to get rid of the x, so we need to substitute something in for x. Here we have a relationship between x and m. So if we wrote x equals something, 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 m, then we could substitute that in and we'll solve our problem. So what we're going to do is we're going to try to solve for this. We're going to put x by itself on the left. But it's kind of hard to, because we got all this multiplication and PEMDAS stuff going on. How are we going to do that? Okay, first step. Well, look how x is buried in all these operations. Let's get rid of the outside operation, which is a half. How do we get rid of a half? We're going to multiply both sides by 2. And then this will be x plus 5m equals 50 times 2, which is 100. And then we're going to solve for x. So it's going to be x equals 100 minus 5m. Okay? And so then we can plug the x into here, and we'll have L equals 2m times m plus 100 minus 5m. Okay, and then we can simplify this. 2m times m plus 100 minus 5m. M minus 5m is equal to minus 4m, right? So that would be 2m times 100 minus 4m. Okay? So that's what L is in terms of m. Then it turns around and says express L in terms of x. Oh man, okay. So now we need to get rid of the m's. How do we get rid of the m's? Well, we're going to write an expression like this. Instead of having x on the left, we're going to have m on the left. How do we do that? Okay, again, we start with the same equation, x plus 5m equals 50, and we need to get m by itself. So we need to first multiply both sides by 2, and we get 100 here, and we get x plus 5m, and we want to get m by itself. So let's subtract x from both sides, and we'll have 5m equals 100 minus x. And then we're going to divide both sides by 5. And we're going to have m equals 100 minus x divided by 5. Okay, and that is what we need to put in the original L equation. Let's see, L equals 2m times m plus x. So the m here, 100 minus x divided by 5, we're going to put it in two places. We're going to put it here, 100 minus x divided by 5. And we're also going to put it here, 100 minus x divided by 5 plus x. Okay, and then we're done. And that's all they asked us to do. We could simplify it, but not necessary. Okay, last one for this section. Y equals 5x squared plus c, 12x minus 2c equals 3. Express y in terms of x. Okay, so the only problem is with like this equation here is that it has a c in it too. We got to get rid of the c. So to get rid of the c, we're going to use the constraint equation, and we're going to solve for c. So let's see, 12x minus 2c equals 3. How about, so what we want to end up with is like c equals something, something, something with x in it. All right? So to do that, we will put 2c on one side, and on the other side we'll have 12x minus 3. Okay, the way we do that is we add 2c here, add 2c here, subtract 3 here, subtract 3 here, and then we end up with this, 2c equals 12x minus 3. And then we divide both sides by 2. Divide this by 2, divide this by 2, we get c equals 6x minus 3 halves. Okay, 3 halves is 1.5, right? So I'll just write 1.5. So now we have an expression where c equals something, something x. That's exactly what we wanted. Now we're going to substitute that into the y equation. So we have y equals 5x squared plus 6x minus 1.5, which is c. So now we've succeeded with part A. Then part B, use differentiation to find dy dx. So that would be part B. Y prime is equal to derivative of 5x squared is 10x. The derivative of 6x is 6. Derivative of negative 1.5 is 0. Okay, so now we've already found dy dx. Hence, find the minimum value of y. Okay, so they're saying that there is a gradient of 0 at some point for this equation. So what we can do is we could say, hey, y prime is equal to 10x plus 6 equals 0. And then we could say that, hey, 10x, we can subtract 6 from both sides. We're going to get 10x equals negative 6. X equals negative 6 tenths, or equal to negative 0.6. Okay, so that is the answer to C. Minimum value of y. I'm sorry, they asked for the minimum value of y. We found the value of x that makes y a minimum. So what we're going to do now is we're going to put it back into the equation. Y equals 5x squared plus 6x minus 1.5. We're going to put negative 0.6 in there. And that's going to give us the minimum value of y. Okay? The other way we could do that, which is probably easier, is we can do what we did earlier, and we can put both of the equations, the original, if we put the function and its derivative in the calculator, we can figure out the minimum value of y more easily. So let's graph these, and we should get a parabola and a straight line. Okay, and then we can look at the table, and this should answer one of the questions. Oops, and look what I did. The table is counting by 0.1s. I'm going to change that to just 1 by doing plus 1 there. Okay, and then let's see. One of the things we want to know is when the gradient is equal to 0, and we found that that was at negative 0.6. Looks like it would be around negative 0.6, right? But between negative 1 and 0. If we want to see it exactly, what we could do is we could do plus 0.1. And then we could see at negative 0.6 that the gradient is 0. Okay? And then at negative 0.6, what's the y value? It's negative 3.3. So instead of like substituting into this equation, x equals negative 0.6, what we can do is just look at the calculator, and then it's going to be negative 3.3. Okay, that was C. Now finally D, the last part. Find the value of C that corresponds to this minimum value. Okay, let's see. We know that C is equal to 6x minus 1.5. So that means that if we know that x equals negative 0.6, then this would be 6 times negative 0.6 minus 1.5, which is going to be equal to negative 3.6 minus 1.5, which is equal to something like negative 5.1. Okay? And that's it for this section.